Today I am going to talk three important elements in the periodic table. One is boron, another one is carbon and silicon. So boron, mainly it forms boron hydrides. In that diboron is important. So diboron can be prepared by using that boron trifluoride reduction with lithium aluminium hydride to form that B2H6 AlF3 and lithium fluoride. So here 2BF3 we can take, and now the reaction is balanced. This is called diborane. And diborane, when it is undergoes the chemical reactions, what are the important product it's forming, that we will see now. So when B2H6 reacts with water, it forms that H3BO3. This is called boric acid or orthoboric acid. So now along with this hydrogen will form. So here 2H3BO3 and 6H2. Diborane reacts with halogen. At room temperature. It forms that boron trichloride by releasing that HCl. And when diborane reacts with base like trimethylamine, it forms the complex Me3NBH3. So this is the compound it forms. Next, boron reacts with ammonia. It gives that B2H6 2NH3. This is the ionic compound, and when you take an excess, and B2H6 reacts with ammonia. This is also excess amount. At high temperature, it forms that boron nitride. So this is graphite-like structure. Boron reacts with ammonia with 1:2 ratio. It forms that borazyne B3N3H6. This is called borazyne. So borazyne is the cyclic structure Borazine is the cyclic structure which is similar to benzene, with alternative boron nitrogen. So here you can see that it is similar to benzene, that's why it is called as a inorganic benzene. It is called as a inorganic benzene. So here the hybridization of boron and nitrogen is sp2 hybridization, planar structure, alternative double bond. So it is similar to the benzene, that's why it is called as a inorganic benzene, and it is isoelectronic to the benzene. So this is important about the boron. Now let's see that carbon and silicon. First I am going to talk about the carbon allotropes. So carbon allotropes, mainly we were discussing diamond. Second one is that graphite, and third one is that fullerene. Third one is the fullerene. So diamond, hybridization of carbon, sp3 hybridization, and graphite hybridization is sp2 hybridization, carbon hybridization is sp2, and fullerene, the carbon hybridization is sp2 So here in the fullerene 20 hexagonal and 12 pentagonal rings are present. Pentagonal rings are present. Okay, and oxides of carbon is one is that carbon monoxide, second one is that carbon dioxide. So carbon monoxide is important and it can form two gases. One is the water gas, the carbon monoxide with hydrogen. Another one is the producer gas, water gas. Another one is the producer gas. So producer gas, carbon monoxide, nitrogen and H2. Okay, next is silicon. Silicon can form silicones. Silicones are the polymers with repeated unit of dimethyl SiO. So this is the repeated unit in the silicones. And another one is that silicates The basic structure of silicates is SiO4 4 minus. SiO4 4 minus. Okay, thank you.